Okay, let's do this and tell some people that we are going to do this. Tweet it out. Tell Discord and this Discord, and that should be good. Okay. So let's tackle Advent of Code day 7. Let's see. Day 7, the treachery of whales. A giant whale has decided your submarine is its next meal, and it's much faster than you are. There's nowhere to run. Suddenly, a swarm of crabs, each in its own tiny submarine, it's too deep for them otherwise, zooms in to rescue you. Ah, that's nice of them. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system just beyond where they're aiming. The crab submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help. There's one major catch. Crab submarines can only move horizontally. Okay. You quickly make a list of the horizontal positions of each crab, your puzzle input. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal position match while requiring them to spend as little fuel as possible. For example, consider the following horizontal positions. Okay, this means there's a crab with horizontal position 16, a crab with horizontal position 1, and so on. Each change of one step in horizontal position of a single crab costs 1 fuel. You could choose any horizontal position to align them all on, but one that costs the least fuel is horizontal position 2. Okay. This costs a total of 37 fuel. This is the cheapest possible outcome. More expensive outcomes, including aligning at position 1, position 3, or position 10. Okay. Determine the horizontal position that the crabs can align to using the least fuel possible. How much fuel must they spend to align to that position? Okay. That's interesting. My first idea would be to take the sum and then average it out to see where to start. To see like what is the average position. And then probably move in a direction to see if it gets lower, right? Because I'm thinking if you have all these values, yeah. We should probably calculate like every position on here to see if what I think is correct. Because I think like if 1 is the optimal position, 0 would be a bit more and 2 would be a bit more, but still lower than all the other options probably. So I wonder if we like take a starting point and then look at if it goes down or up depending on which way we move. I think it should be something like that. And probably like if you could also brute force it to just like split the problem in half. But you need to have multiple measurements to know, right? So if we go between 1 and 10, you probably take readings at like 3 and 6. Look which one is lower and then focus on that one to see which side produces lower numbers. But you could also do like 5, 7 and 3 and then go from there. Interesting. Let me see. Let's just play a bit, and I think we start with the test input because this is just one long number, and see if my idea works. So yeah, I would sum up all of these, then take the average and start from there and look which side we need to go. That would be my estimation. You could probably also take like cut out the outliers. So if you sort them by number and you skip the first few and the last few and then look what your average is. That should give you a better idea, because you cut out some of the extremes. Because in this case, if you take all these numbers, skip the lowest 2 and the highest 2, you'll average around 2 to 3, I think, based on this. So that would give you a good idea. But yeah, how much of this should you skip? But even still, with the high numbers included, I think you'll get like a starting point where you can move from. I mean, it all depends on like the shape of the data. I think it's best to just take a stab and see where it goes. So let's create a day 7. Day 7. And I turned this into do both parts because I optimized yesterday's challenge to just spit out both parts, because it didn't make sense to have 2 parts there, because it was just spit out the value at day 80 and at day 256. So let's see, in this case we have just this 2 lines. So we do var positions equals this, and then we can delete this and write code here. And program needs to run day 7. Actually, I don't even need to declare it here. I can just do this. Okay. So let's see. So my first idea would be to take var average is positions at average. Do we have an average? Yeah, we have an average function. Is this int as well? No, it goes to double. Okay. So we can do math.round. Do an int. So we do console.writeLine inputs. Boom. Positions. We do 0, average. So let me just run this now. Input string was not in the correct format. What do we have here? Ah, I need to split that. My bad. So we need to do split, comma. King Mask. Hey, hello. Welcome. This is live. Yeah, this is live. So yeah, thank you for chatting. It's always nice to see people interact. So yeah, I'm doing Advent of Code Day 7. It unlocked today, so that's what I'm doing right now. So basically the challenge is you have a list of positions, and they all need to unify into one position with the least amount of moves. So right now I'm just writing some code to see what the data looks like. So we have, I need to have positions that count. So if I run it like this, cough once if this is live, cough twice if you are kidnapped. So cough 7 times, what does that mean? Just, I'm doing fine. I made myself a cappuccino and I'm enjoying Advent of Code. So let's see. We have 1,000 inputs. The average is around 479. Okay. I'm just wondering, like, so we do int calc movements. Let's see, and we'll we take an IEnumerable. I think, is this as a list? Yeah, sure. Okay, we do list int positions int target. So we do long sum is 0. We can probably do positions select x math that absolute target minus position. Sum actually. Why does it complain? Ah, minus x, right? So we can actually write this like this. So let's see. So int target is average minus 1, target smaller than average plus 1, target. Let's just write out the ones surrounding these. Let's see. Oh, life is late for me. Hey, for what are you learning code? Planning on making a game or just for programs? No, I'm just having fun. Weirdly enough, I do this for fun. I've been programming since I've been 12 years old. I'm 38 now, and I still enjoy programming a lot. So this yearly Advent of Code challenge, it's just me having fun. So let's see, positions, target. So let's just say, we wrote this. Now let's write out the ones that we know. So I can do console.writeLine. See, like this. Let's see, we do target minus 1 is this. Oh no, it's actually just target in this case because we modify this. So this should give us an idea of how much steps it would cost, one below exactly and one above. So looking at this, we need to go lower, right? So what we can do is we can half the search space actually. Let's see. So let's see, we have int best is, let's do this. Dun, 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 dun. Let's see. So we set our best. And now we need to look which way we go. Bool lower is, let's see. Because we need to calculate the next target. Am I really the only person watching? According to my stats, there are a few people watching, but not everybody likes your talk. So yeah, it could be. I don't really get a lot of views on these. So thanks for hanging out. If you have any questions, feel free to ask. I'll try to answer any questions that you have. Let's see. So first I need to determine which way to go, like up or down. So I try to determine here if I need to search up or down based on my current search. So let's see. So we do int target lower is math.round average divided by 2. We make this an int. Int target higher is, we do the same, but we do, it's actually Because you divide the search space, we do average plus target lower. So now we do target higher. Let's first store the target, the values. So we do int cost lower is this, target lower, int cost higher is this with target higher. And I do bool lower is cost lower smaller than cost higher, and based on this we try to move. Let's see. So and now I need to determine which way we go. So if lower, then we go so this actually should be like target. We can remove this exploratory code because we will update target. If lower, then target becomes target lower. And we actually do the same thing here. And else we do target is target higher. But we also need to remember like the bounds that we search, so we don't zoom out anymore. So let's see. I'm just thinking. So let's see, we have actually, so we do int, let's see, int lower bound 0, upper bound 0. So if we do this search, we set our target lower and higher. So this one becomes the bounds. So let's see, we do target minus lower bound divided by 2, right? And the same for the upper, actually the upper bound should be the same that way, I think. You can always do it like this. This will keep shrinking the search space. So after that, we just say, after this, we can say lower bound is target lower, upper bound is target higher. And then we need to determine the new targets after this. Because we need to set 2 new targets here. Let me think. Here you say lower bound is target. Upper bound becomes upper. Okay. Let's see. Upper bound becomes actually target was the upper bound because we calculated that and we determined that it's lower, so we never should go over that. And in this case, we need to go lower bound is target. Right. And this also means that we need to change how we do this. So if it's the lower, then we actually need to, let me see. Am I reasoning correctly here? Yeah, if you go lower, then you cap the upper bound, right? Okay. So then you go, target lower is this, and target higher is that. Actually, no, it's this. So we could just call this step size. Let's see, target min lower bound. Am I doing this correctly? Let me think. Because you take, yeah, this is the difference, and this is what you need to subtract from that. So if you have 5 and the lower bound is 2, you get 3, you remove half of that to go to, yeah, 3.5. I need to make sure that I don't mess this up. And higher would be, so this would be the range, search space equals this. And then you have a minus and a plus, like that. It's a lot more complicated, or I'm making it more complicated, but than I first thought it would be. And I need to clean this up later, but I first need to like visualize this for myself. Okay. So the first time we do it like that, we assume down, okay. So we have that. Target lower, target higher. We do the same but the other way around. So in this case it will be upper bound minus target, and now we do target lower will be, let's see, yeah, we move up, so we do this, and we move up twice, right? Let's see, search space is upper bound minus target divided by 2, so that will be target higher. But if the lower bound is already that, oh, we just need to, we don't have to actually do that. We just need to update target here. So we set the lower bound, and target becomes actually target plus search space, right? Because we just set one. Same here. Upper bound is this. We set target minus lower bound. No. If we need to go lower, we start here. Oh yeah, we look to the lower bound to see how much we can remove. So target then becomes not target lower, but target becomes target lower minus the search space, like that. Let me see. Upper bound, so you get target lower. So here it should be target higher is target higher plus search space. Okay. I need to write all this out because it will be right line. Target is And then we say lower, higher, like that. We will try target next, limited range search space between blah and blah. Okay, so we have lower bound and upper bound. And I feel like I should do this a few loops to see. Let's see, because now we do. I can just do int next cost. Is calculate movement. Target. Let me see. So we have next cost. And we need to keep track of the previous costs. And previous cost. So many variables. I'm sure we can make this simpler somewhere, but so previous cost will be math.min cost lower, cost higher. Let's see. I can do is math int dot max value. And we do this to the next cost. I'm just thinking what would be our exit condition if we no longer have a value that's higher. Now, if we get one that's continuously higher, let me see. Let me see. I think like if the search distance is 1 and there are no lower movement, that should be the exit, but I can't reason about it. I need to see some of this right now. Let's just do lower is oh yeah, I can do it like this, right? Which way did we go here? I think lower, right? And that it depends on which way we went. Let's see. Let's just do a few loops. By now I just need to step through it and see it because and I need to make this like previous and cost next cost. because I think this could just be previous and next. So I just take this as the previous, the other one as the next, and then we'll know what to do. So let's just say this is previous, this is next. But this also means, you know, we have to keep track of a direction and flip if it doesn't work. Man, why is this so hard to do in my head? Sometimes you just need to execute code and not just do it all in your head. So let me see. I'm just going to step through it once. Okay, so it's clear that lower here is better. But I don't actually shift them over, right? So what I should do here is previous cost is next cost. Dun, dun, dun. So let's see, target is lower, we will try 119 next, limiting the search space between 239 and 479. Okay, actually we should decrease this to 478, and I think the floor should still be 0 because we don't know, we have not hit a flip, right? But that's because I have the previous value here, right? Let's see how lower bound got set, by the way. This is incorrect here. Lower bound should be positions.min. So like the lowest value there is our lower bound. Okay. So far so good. Let's just run this again. I actually want to run it just to here. So this should spit out -1 next. What? That's not correct. Target is low, we'll try -1 next, that's cool. Let's see, because search space is target minus lower bound divided by 2. And then we have target low, no, actually we came from target upper. We move from the current target, so that is incorrect. So if we need to go low, we take our current and we do this. Okay, right. See, it helps to step through it and work it out. So let's see. We will try this is correct, between 0 and 287. So okay, that is correct. And lower bound should actually, if you need to go up, would be target +1. Okay. So now we have previous cost was this, the next one. Okay. We already overwrote that. Is that correct? I think we still need to do if next cost lower than best is next cost, something like that. It's just awkward because of the first time. Previous goes slower than next. I can't make sense of these values anymore. Oh, we actually need to target best, right? Because if neither of them are better than best, that's an interesting one. Let me see. I think that I start this off wrong because I need to know like lower, higher, but I don't have a starting point. So this is causing me some headache, but let's see next cost. Because this previous cost is now wrong, because for the first time I should have said I wonder if I just take, no, let's see, if I take this, I could just, yeah, the problem is that I do two calculations here. I should just, I know what I should have done. I know what I should have done. Because if it's lower than half, I need to go lower. Is that correct? That's an assumption. Because my reasoning is like I have 1,000 entries, my average is below half, so I need to go down. But that doesn't have to be correct. Because I can just start at a point and then check the result and then move the other way. And since my full range is open, that should be correct, right? Let me think. I'm sorry for the dings, but I'm getting messages. Let's see. Since I open up the search space, I don't think that should matter, right? We have lower bound, position min, upper bound is target higher. But the upper bound should also just be positions.max actually. I'm just thinking, if I just make an assumption and try one area, if I don't limit my search space, it doesn't really matter. Previous cost, next cost. Okay, so if these are my total bounds and I just pick one in the middle of those and I take a position but I have nothing to compare it to, how do I decide which way to go? So for my feeling, I need to like do this one and then it limits my range. So let me just do this now and get it out of the way. So I do bool lower, so do you the first setup. If lower, else, and then you explore from there and you have a guide where you go to. So if it's lower, upper bound becomes target -1. Is that true? I'm thinking if I just did the naive approach, I would have already been done, but then it will kick my ass later. Okay, I don't know why this is causing me so much issues. Let me just run it again and see if I can work it out. So yeah, this works in limiting the space. So if I run this a few times, okay, let's just run it till here and see what it comes up with. Let's see. So what is the previous cost? 34664. Next cost. Previous and next are the same. Okay, so if this is already the same, so does that mean this is the answer? I should try this on the test input just in case and see what it comes up with. Let me see. Three, okay. But the answer should be 2. Let's see, or 1. Let's see. Which was the answer here? Position 2 is the cheapest. So why do I end up with 3? Let me see. Probably because it goes up again and then excludes it because of this. Right, so... and then we can say, let's see, previous cost, next cost. So 39 is lower than 59, that is correct. We write 3 next. Target is higher. So that is because it's determining the change wrong. Because we have a direction that we're going and if it's better. So like, so in this case, we do this lower, pull better. If not better, lower is not lower. I think that is actually what we should do. That is weird. Let me just step through this. Boom, 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 boom. Let's see. So we have here next cost, previous cost. So this is just the, let's see. So the first time we determined that we need to go lower. We don't need to switch this actually. We just need to do, the first time this doesn't matter. Okay. I should probably prime this example to be correct. So then we do, because we don't want to switch it the first time. Okay. Dun, dun, dun. So switch these around so that we don't influence the better. If lower, switch because it will falsely trigger the better check. Something like this. Let's see if this is correct. Wait, what? Didn't I switch these? Wait. Okay, wait. So actually, yeah, I have this logic the wrong way around because it's better if the next cost is lower than previous cost. And then I still need to do this. Okay. Okay, let me debug this. So it's better. So we still need to go lower because we were going lower. Upper bound was 16. Now it will be set to target -1 because we know that current target is better. Is that correct? It all depends on if we're still... Let's see. If we went in the the correct direction, we can wall off the upper bound. Man, this is hard. So if it's better, then we can do this. But we haven't explored anything in between, so we just know that this version value is better, but not that the previous ceiling is better. Only if it's wrong, then we know that we don't have to go there again, right? So let's see. If it wasn't an improvement, we can cut off the direction that we're going in. So then we do if lower. We can set a lower bound. So if we didn't improve while going down, we can set the target as a lower bound +1, so we can only do one more than the current target. Because this one isn't an improvement over what we did before. Else we can set upper bound is target -1. So if we didn't improve while going up, we know that we at least don't have to go there again. Okay. So that removes this part. I think we'll just have to work this out step by step. Yeah, I will have to walk this whole thing, because I know in my head how I would do it with pen and paper, but it isn't translating to code right now. So let's see. So we previously had 59, we now have 39. So we like our target, which was 5. Okay. So if it's lower, so we have target minus lower bound divided by 2, because we want to go lower. So now we go to target minus 2, which is 3. Let's see. We improve our best. This should probably be targeting best. Right. Or do we care about just which way we're going? I don't know. Okay, let me just see the previous cost here. No, we need to target best. So we previously had 39. Let's see. Target is 3. Is it the same? So is that the same as 5? So 3 and 5 have the same cost? That is weird. Oh, we already targeted 3. That's the issue with this. Because we do 2 targets. Man, this is annoying. Let's see. So if lower target is target higher. Wait, no. Is target lower. Else target is target higher. Because we need to update this. Okay, let's see. So target becomes 1. So we calculate the target for 1. Let's see, lower bound becomes target. Wait. How can the fuel cost position 2 was, okay, my bad. Okay. So now we set the target was 1. So now we say 1 is no go, we need to go higher. So that is correct. Let's see, search space becomes 8, oh my god. Actually, we already knew if we do this, if it's lower, then we can say target upper higher is target. And then we update that, and in this case we can say target lower is target. Okay, we're getting somewhere. So the first time we say, let me just put it here. We tested 3 and 8. It doesn't display that here, but we arrived at 39 for 3. And the next one, limited search space. Okay, I thought it would be higher already. We limited this, right? Lower bound and upper bound. Upper bound. And this becomes lower bound. My bad. So we start with taking 2 samples to know where we're going. So now we're here. Limited search space between 0 and 5. Okay. So now we didn't improve when we did step 1, because that is 41. So we now limit our search space further. See, we go from 39 for step 3 to 41 for step 1, and now we limit our search space between 2 and 5. Okay. Which was the target actually now? Target was 3 now, okay. But we already had a target of 3. It's not better. So we set an upper bound of target -2. Is that correct? Because this is actually let me see. Because we didn't improve, but we matched our best. So do we really need to go in another direction? Probably, because we didn't improve. So now we need to make sure that we have math.max 1, comma. Because if it's 0, then we never move on. Same here. And this, I probably need to validate that the new target is still within the search space, and if it isn't, then I should be, we should have our result. So now we still don't have a battle 1. So we have lower bound. Let's see. So our lower bound and upper bound. Okay, so if lower bound equals upper bound, break console.writeLine, we found our answer, which is actually target. Man, this was painful. Just return here. So we can just do, we can just do while true, actually. And I really want to go back to this code and clean it up, but probably not now. Because this was painful, man. Very painful. Okay, so the answer is 3. 2 here. And I probably need to answer lower bound next cost no, actually previous cost. Whoops. Okay. Actually best would be the answer then, right? But the answer should be 37. That is weird. It already arrives at that bounds before even having to calculate it. But it's weird because it never hits here. So yeah, okay, makes sense. So there, okay. So what happens when I run this on the big input? Kind of scared actually, because it's been far from smooth this. Okay. And it's not the right answer. Your answer is too low. Oh my god. Okay. So let's do lower bound -1. +1. I'm very curious to see what this gives. So yeah, actually the one below it is lower. Let's see, target is lower, right? We will try this one next. Let's see, because we know this is the answer probably, I'll just add 2 more. I want to make sure that the code actually does it and not just me hand doing stuff. Actually 240 is also lower. What the? There is probably a bug in the way it limits its scope, but let's see. Okay, so 339 should be the answer. Did it say it was too low, by the way? How much fuel? Ah, yeah, and also I put in the wrong answer. I put in the wrong value there as well. So let me see. So the answer should be 339. Let's see. See, that's correct. And now the issue is, why doesn't my code end up here? So let's see. Somewhere it limits the scope, like here, in this step. And it says, okay, it's lower than that. So let me just set a breakpoint for that exact part and see what it does wrong there. If target equals this result. Okay. Actually, I should probably have, because now the lower and upper bound, no, they are still fine. Okay. And the best is still higher than what we submitted, right? Okay, let's see. Okay, so we are better. So we are still going up. Let's see, lower bound 314. What was target? 441. Okay, so we're still going up. Actually, wait, what? Let me think. So currently, don't I need to also adjust the search space while searching? No, because you can't know for sure. Only if you took a wrong turn, then you can cut off a point. Okay. Okay. So this is still good, and now it's not better. Okay. So now we targeted 355. So that is good. Lower is false. So we set the upper bound to 355 minus 1. That is fine. So the next target becomes this. This is fine. We're still not better. This time it's lower. The target is 355. This was not better than what we had before, so we move up the lower bound. So this is also correct, 336. Okay. So the new target becomes 345, which is fine. So far it's still good. Let's see, it's not better. So the upper bound becomes 345, 345. Yeah, that's also correct. Okay, now we equaled our previous, because target is, we already did. I should probably, because the same thing gets visited more than once, we should probably not do that. Because that's a bit of a shame to actually test the same number more than once, because we already know the value. But okay, let's ignore that for now. But in this case, that could be an issue because we equal it. So we cannot exclude it. I think that's actually that's this plus run, right? If it's actually if it equals 0, otherwise we do 1. So in this case, we won't limit the range to exclude the value that we got, because this might as well be the best value that we got. So now lower bound becomes 41, which is fine. So target becomes 34. No, wait, lower bound 41. That's not correct. I wonder if okay, if I run it like this, so the first time we can skip that. Still better. What's the new next cost? Okay, I think this might be it, because better actually has to be better before we move another direction. I think this is it, right? Does it? Let's see. Did it get the right answer this time? I just have to check. I think that was it. We had to determine that an improvement was actually an improvement. Huh, man, that was rough. How long have I been streaming? I think it feels like forever. Over an hour already. Hi, unfortunately I can't watch your stream now, just wanted to say hello. Well, Daniel, it's really kind of you to say hello. I just went to a very rough patch here with the code. I'm just glad I got it done and actually figured out what it is. I still want to go back and clean this up. But yeah, this should be good now. I'll watch you upload though. Okay, well, prepare for a rough one, because it really took a lot of me to get this worked out. I knew exactly what I wanted to code in my head, but it didn't work out the way that I wanted to, and it took me a long time to get here. So this is very finicky to get better, and it's not the prettiest code, but I will clean this up when I have some time, and yeah, let's just see what part 2 is. So yeah, thanks for stopping by. It's really appreciated to say hi. Like everybody that says something in chat, it's a nice motivator. Same for the likes and comments on videos. It's just really nice to know that you're not streaming into the void. So yeah, let's see part 2. The crabs don't seem interested in your proposed solution. Perhaps you misunderstood crab engineering. Well, I've misunderstood a lot of other things today, so why not? As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change of one step in horizontal position costs one more unit of fuel than the last. The first step costs 1, the second step costs 2, etc., etc. As each crab moves, moving further becomes more expensive. This changes the best horizontal position to align them all on. An example. In the example above, this becomes 5. Okay. Okay. Okay, so that is fine. So I just need to actually update this version, and then we have the answer. But how do you actually do the +1 for each step? My brain is a bit fried, so so what I'll do now is something nasty, but it will work Okay, so we do dictionary int, and we do distance, actually distance fuel cost. Let's just say fuel cost. Boom. I will do here for int I is 1, 0. I smaller than 1,000. Okay. So we'll have sum plus is I. Okay, what am I doing here? Okay, let's see. Like that. So for 0 it will be 0, for 1 it will be 1. Then for 2 it will be 1 plus 2 is 3. Should be good, right? So we do fuel cost dot add I dot sum. And then we'll just do this. And let's just rename this to part 1. And I'll just copy this whole thing, and I should probably just have like, I could do that. Because this is basically a func. Func. It returns an int, and it has these inputs. Oh, the last one is the result. Okay, so we do this. We call it calc movements. Right. Like this, and then we do var part 1 equals this, and then we do calc movements. Var part 2 is both. What's the problem? Cannot assign void type to implicit. What? Ah, sure. Like this. Right? We do this solve. And now instead of all these references here, I need to pass in this function. I already did it, so. Alright. We can remove this one. And let's make sure that we do our test input for now. Okay. I messed that up nicely. Let's see. Let me do part 1 first. See if this still works. So this one is 37, answer to, okay. So what's wrong with the second pair? Let's step through it. Actually, I should just, I could just do, we do positions, 1, 2, let's do a 6, and 5, yeah. Ah, wait, this also means... Wait, let me check. 0, 1, 2... Yeah, okay, it still improves the same way. So my function works, that ain't it. But there is a different problem, so let's see. Ha! Okay, so... The fun thing is that I shot in the rows the first time. So I hit a bullseye on my first attempt. Boom, boom. Okay, let's see, because this is funny. So it will never get there, but it has an upper bound and a lower bound of 4. Let me see, so if it's not better... And in this case, like, okay. Or math.apps upper bound minus lower bound is 1. And then I still don't know if it's the upper bound or lower bound because it's not better. Actually, this one can be here. If we can just say if it's not better, but the absolute range is just 1, if lower answer is upper, else answer is lower bound. Right? It's a weird test case, and they probably made it like this. So like if I run this, answer is 4 and this is wrong. Okay, great. Oh, but it also hasn't evaluated yet. I probably should keep track of which one that were tested, like I said before, to make sure that you don't do dupes. Okay, well what I could do is, besides best, also track best index. Best index target. And every time best is improved, the target is already updated here. So we don't even know which target we hit. So this code should go somewhere else, actually. So this can be removed here and should go here. Else best index is target, best is next cost, right? So let me see, actually if you repeat this, the range was already one here, but not all indexes were tested. So I'm trying to see from, okay, how can I make sure so if the range there is 1, I wonder if did it even go to, no, because it never became this, because it couldn't remove it for some reason. Because the first time we already had the best. Man, that's weird. I just wonder what the best way to do this, because I can tell I would be able to tell, like, if it repeated the same steps within this range, because I need to make sure that it tested the upper and lower bound. Boom, boom, boom. Actually, I can just say, like, if the range is just 2, just test them again and be done with it. Okay. This isn't the beauty prize, and I really want to refactor this, but not now. So let's do int lower A is this, and B is this. So we do lower bound, upper bound. If A is smaller than B, then we have lower bound A, upper bound B. So this comes down to still having a less than optimal part in my solver, because basically all I really had to do was switch out this function with the incremental fuel cost. Answer 5. Okay, so now it works. So the tiebreaker, the fact that the first attempt that I did was already the best shot, kind of introduced a new problem, and I wonder if that even presents in the real answer. But let's see. Given key was not present in the direction, so there's somebody that has to move a lot. So I have to increment my search space here. So let's just do that. Boom. Okay. 320, is that correct? 108.65, 108. It doesn't look like it's the correct answer, actually. Because this one is lower. I wonder if it's this code that hits. No, it's not that code. It's actually, it limits the bound. Let's see. So it starts here. It doesn't do a lot of iterations, so I can actually just walk through this to see why it doesn't work. Boom, 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 boom. Let's see, we're between those. Actually, the 107 was lower than what I saw there, right? Let me see. Wait. Best index 409. That is weird. Hmm. Really curious to see. Best index. So this value was already better than everything that we saw. How do, this is weird. Okay, I need to start at this, do this from the start because there's something weird going on here. Let's see. So best. So we already have a value here. And this is lower than everything that we see there. So the bandwidth is 240. It actually could be that the one that we take is better than all the ones that we see. Let's see, target lower. Previous cost, count moving targets lower, next cost. So both of these are worse than actually the best. So okay. So yeah, my approach here is a bit bad. That's funny. So I'm just thinking. I think the whole thing, how I set this up, like starting with 2 measurements, in this case 3 even, is just wrong. So I should probably just do this one and then decide to go down and not do another one here. So I think the best what I could have done was take like 1/3 of the search space, then move the other one to another 1/3 and move from there. And now I do 3. But I really don't feel like rewriting this, man. So I could actually let me just do it like this because I really don't want to, but let's give it a shot anyway. Okay, so we do best is this, best index is target, right? we fuck all the suck space. We don't like that at all. Do we even is it even used? It's not in the loop, right? No, inside the loop we don't use those. So yeah, that is fine. So I can just do target -1. Do I even use the previous and next? Yes. So I can do previous is best. Next cost is let's see, and we can do target larger than positions that count. We do 1 else -1. So we do target plus this. Target is this. Just do target. And actually I think we can skip all of this. I can do bool lower is target lower than this, and I can do lower -1 + 1 like this. And then I think I can skip all of this. Right. And now we just have a simpler approach. Let me just see if I thought of this correctly. So now we targeted, so best index is 487. Where are we? Okay. Wait, this is weird. Stop. Target. 470. Okay, that's fine. Best index is target. Okay, 478. Target 478. Best index is still 479. Okay, that is great. Is it better? Great. So we move down. Actually, I could have capped off the upper range here, probably. Just to make the first step better. No, I don't know that. No, I need to stop doing this. It doesn't matter. Because I think if I run this now and I just let it run, it should get, answer is 800. And that is not correct because these are higher. See, because that's the bounding thing. Okay, this is dangerous. I make a mistake here because it might shift over or jump over the answer too big. If better. Yeah, that means we can set actually the upper bound. At least I think so. Target else lower bound is target. If lower, and the same for the inverse, and this will, I think this will limit the range that we do. Let me just see if this is correct. Still not correct, but it helps a bit. Let's see. I just need to step through this again to make sure that I do it all correctly. If better. So we tested this target. Let's see, best is this value, right? Add watch. So this one is lower, so yeah, it's better. That means that this is now our upper bound. So let's see. We already had that. Best is next cost, right? Okay. So lower bound is 0. So we remove this from this. Target is this. Okay. So this is not an improvement. So now we set our lower bounds because we don't want to go there. And now we go up again. Right? So target becomes, which is the upper bound? 120, so target becomes 3. Okay. Ah, okay. But, so here is the case. We start from somewhere that we were at 400 something. Then we go down and it's bad. So we want to go back up. So when we go down there and we go back up, we limit the top. Boom, 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 boom. Previous cost is still set here. The problem is that you don't know which way you jumped. So now it says, well, actually, let me see. Because it says we need to go up, and that is true. So it's not better than the next, not better than the best, but it's better than what we previously had. So the question is, do we need to compare against what we previously had or against what we... Let me just check this. What happens if we do previous? So if we run it like this, let's not hit breakpoints right now. Okay, so now we get the answer. And it actually seems like this is the correct answer. And once again, it's actually the average one, right? Okay, so in here it just keeps limiting the search space. Yeah, okay. Whew, this was a tough one. It wasn't a tough one, but it took me way too long to implement this correctly. So yeah, as for this last bug, what I needed to do was to make sure that I keep improving, not that I improve upon the best answer I ever had. So yeah, that was the trick here. Man, it really sucks that this cost me this long to figure out. It's nearly 2 hours, man. Huh. The funny thing is that I think once again, like by taking the average, because like target, yeah, I was off by 1 from the average. So as the costs go up as you increment, actually the only reasonable answer means has to be that it has to be close to the edge. So actually for part 2, what would make more sense rather than to like cut up your search space in half every time would be to just step 1, right? So you take your average, you look 1 above, 1 below, whichever is better, and you move on from there. Because if you look at how many steps I need to do here, let me run it. It takes quite a few steps, right, in here. So it tries, it starts with 479, right? That's the first one that it tries. It then checks which direction to go, and it goes 1 down, and actually this one is the best value. This is the answer that we're looking for, so it's 1. So the second calculation that we do is already the correct one. So instead of trying to narrow down the search space between 0 and this value, we could just walk from this one in the direction that we're headed, and we would have seen after the second step that this was the answer. But, well, yeah. Because you calculate the average, it has to be around that answer. I just think like if there was weird distributions, because as the values move on, it becomes more expensive. But in the end, the lowest average move will have the biggest impact, I think. So yeah, actually from the way that this calculation goes, I should have maybe done a different strategy for part 2, as I said, but yeah. Just this basic solver of like finding the optimum value. It's like a guess the number, like below, and it doesn't matter which number. It can say below 100 or below 10 million. If you can guess and get a lower or higher answer, what you do is you always split your search space. So for 100, let's say it's 13 or something. You guess 50, lower, 25, lower, 13, and yeah, then you have it. But so you just always have your search space to make sure you don't have to do lots and lots of calculations. Yeah, so in theory that should have been a very easy day, but it took me forever to get right. Just the implementation of the algorithm that I have in my head, it just took forever. And one of the complications was that I tried to like the start before you enter the loop is where it went wrong with me. So yeah, I'll probably revisit this code someday. Right now I have a headache from all of this. But yeah, it's always fun to get it fixed and get it right. Whew. I wonder what the other days has in store. So yeah, I'll finish this for now. Glad to have fixed it in the end, and let's see what tomorrow holds in store. Thanks for watching, and maybe see you tomorrow. Bye bye.